This is a little video about the triangle inequality, about the relationship and the restrictions on the lengths of the sides of a triangle. Specifically, if we have two sides and we know them, how is the third side defined by that? How is it limited? So we start with this triangle PQR. PR is fixed at 20 centimeters and PQ is fixed at 5. So we can rotate Q around to get different triangles, but PQ and PR stay the same. The question is, if you have the 20 and the 5, well, let's start. How big can QR be? Could QR be 100 centimeters? Well, if you stretch out PR and Q as far apart as they can be, so that it's not even a triangle anymore, it's just like a straight line. You know, PR is still 20 and PQ is still 5, and the distance between Q and R is 25. So that's like an upper limit. We can't do that because that's no longer a triangle. And if you see, once we get a triangle, then QR is a little less than 25. Here it's 24.9. So we kind of know that now 25 is this upper limit. And we'll just bring that fact down here. So now let's look at how small can QR be. Could QR be just 1 centimeter? Well, as we bring Q closer to R, we realize this side of 5 centimeters is not large enough, and this distance will never be as small as 1. How small can it be? Well, let's get Q as close to R as we can. Again, it's not a triangle anymore. Q is right on the line PR. And the distance between Q and R now is 15. That's as small as it could be. That's like a lower limit, but it actually can't be that small. It has to be a little bigger than 15. If we just raise it up to become a triangle, we see 15.1. So QR has to be bigger than 15. And you might have noticed, and I'm going to pull Q up a little bit so you can see it more clearly. You might have noticed that in this triangle, QR has to be less than the sum of these two sides, less than 20 and 5, because that's an upper limit. And it has to be greater than the difference between 20 and 5. So it's got to be less than 25 and bigger than 15. Let's look at another example. Okay, so now we have sides that are closer together. We have a fixed orange side that's 7 and a fixed green side that's 5. And we want to know, how big can MU be? This is triangle ZMU. So how far away can U be from M? I can pull it as far away as possible. So now it's not even a triangle anymore, and U is 12 units away from M. There's the 12. The green 5 is still the length of ZU, and the orange 7 is still the length of MZ. But this isn't even a triangle, so UM cannot be 12. It has to be a little bit less than that. When we pull this up and make a triangle, it's 11.9 here. So again, in this example, just like the one before, MU has an upper limit that's the sum of the two sides, the 7 plus the 5. Now if we look at a lower limit, well, how close can U be to M? And it can get much closer than it did before. But if it gets as close as possible, well, this lower limit is the difference between the 7 and the 5. The 7 minus the 5 is the 2. That's not even possible because we don't have a triangle. So if we lift U up a little bit, it's got to be a little bigger than the 2. The 2 is this lower limit. So we see again that if we look at a triangle that we know two sides of, the third side has to be between the difference of these two sides and the sum of these two sides. It has to be bigger than 2, bigger than 7 minus 5, and less than 12, less than 7 plus 5. Let's look at one more example. Here we have an isosceles triangle. Two sides of 8, a purple 8 and a blue 8. This is triangle BVW. And if we want to know the limits on side BW, we just stretch W as far away from B or B as far away from W as we can. And again, it's the sum of the two sides. 8 plus 8, 16. BW has to be less than 16 in order to make a triangle. The more interesting case is, what is the smallest BW can be? And because these sides are equal, they can exactly overlay one another. The lower limit is actually 0. It just has to be bigger than 0. It can be any tiny amount apart because it's an isosceles triangle. So this is a fun example to explore. And the more formal expression of this triangle inequality, if instead of 8 and 8 and the sum of 8 and the difference between the 8s, we use symbols. If it's one side of a triangle has length A and another side has length B, well, the third length C has to be less than A plus B and greater than B minus A. Now, since I don't know which is bigger, B or A, I put absolute value signs around it. Bigger than the difference between B minus A. And that's the triangle inequality.